All right, team, we're going to review expressing a radical in simplest radical form. So I want to point a few things out first before we begin. Some radicals are perfect squares. So for example, 36 is the same, or I'm sorry, 36 is made up of 6 times 6. So the principal square root of 36 is 6. Other numbers, such as the one here, have to be broken down instead. Because the square root of 50, if I were to go to like Desmos, is going to be a decimal. In fact, let me ask my watch for a second. What is the square root of 50? Okay, my watch told me it was 7.071. That is an irrational number, and we in math don't like irrational numbers. It's not that we don't like them, I shouldn't say that. We don't like to work with them. Okay, so because this decimal goes on and on forever and ever. So we don't want this. So we don't want a decimal here. What we want to do is break this down into a simplified version where there's a number outside and then another number on the inside. That's what our answer is going to look like. There's two methods. One is the factor tree method, and that's going to be in the yellow post-it. The other is the largest perfect square method. Okay, let's start. I'm going to do the factor tree method twice. Let me first start with just the first numbers I can think of. So factor tree method works by breaking down 50 into two things that multiply to 50. So I'm thinking 10 times 5 is 50, so I break it down like that. 5 is a prime number, so you stop here. 10, though, can be broken down into 5 times 2. Those are both primes as well. So we're done breaking it down because I've landed on prime numbers. All of these are prime. In fact, 5 times 2 times 5 is 50. Every single number is a product of prime numbers. So this method will always work. But how do you write your answer? Well, first thing we need to do is we need to look at the ends and look for pairs. They don't have to be next to each other, they just need to exist. There's a pair of 5s, so I circled them in green. Pairs come outside the radical. And there's a single 2 that stays on the inside. So the answer to this, as a decimal, is 7.071, but it's also 5 square root of 2. If I were to type this into Desmos, it would give me this answer as well. Oh, whoops. Let's backtrack. There we go. Okay. I'm going to move to the largest perfect square method. So largest perfect square method, you must put a perfect square in the first line. So whereas the factor tree method, which was in yellow, you can choose any numbers that multiply to 50, in this method you have to choose the largest perfect square. So you have to kind of know what the perfect squares are. I'm going to list perfect squares: 1, 4, 9, 16, 25, 36, 49, 64. I should have stopped my list at 25 because there's no way that I can break 50 down into anything that's bigger than half of it. Half of 50 is 25, so it's got to be one of these perfect squares. Now, coincidentally, the largest perfect square that is a factor of 50 is 25. Because what does it mean to be a factor? It means that it goes into the number nicely. It has a dividend with no remainder. Or to state that more simply, 50 divided by 25 is 2, not 2 point something, just 2. So we found it. This is the one we're going to use. That goes on this line. And then, make sure you ask yourself, 25 times what is 50? It's 2. 25 times 2 is 50. Because you found a perfect square right here, if you know how to square root it, you just square root it. The square root of 25 is 5 because 5 times 5 is 25. And we can't square root the 2 because it's going to be a decimal and we don't want an irrational number or decimal here. And so our final answer is 5 square root of 2. Notice the answers are the same. the answers are the same. This person chose 10 and 5, though, to factor it down. This person had to choose 25 and 2 in order for that method to work. It is possible for someone to do the factor tree and happen to pick the largest perfect square. And if so, this is what's going to happen. The pairs are going to line up next to each other like this. But at the end of the day, you still get the same answer. One of the 5s comes out, and the 2 stays underneath. Okay, so I hope that clarifies. We're going to do one more. Before we do one more, I'm just going to hit Show Solution real quick. So I want to show you what Delta Math does. Delta Math will do the orange sticky note way, which is the largest perfect square method. But they actually go so far as to make a table. And they're like, what perfect square divides into 50? And they even started way back here at 49. They said 50 divided by 49 is a decimal, no good. 50 divided by 36, 36 being another perfect square, is a decimal, no good. 50 divided by 25 is 2, ding, 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 ding. That's how we know to break our 50 down into 25 and 2. The square root of 25 is 5. The square root of 2 stays the same. Notice that no matter what way you do it, you get the right answer. But you have to make sure you're following the rules of the way you're choosing. So let's do one more example. Here we go. Okay, here we go. This one is square root of 48. If you're going to use the factor tree, you are not limited. You can pick any numbers that multiply to 48. I'm picking 6 and 8. Ooh, okay. Let's find some pairs. Here's a pair of 2s. These 2 are a pair of 2s. And then there's a single 3. Notice I'm not circling this 4 here. Don't circle the 4 because you broke that down to 2 and 2. You're only allowed to circle prime numbers. Prime numbers are numbers that can't be broken down. All right, so according to this, I'm taking out a 2 because there were a pair of 2s. There was a second pair of 2s, so I've taken out another 2. And then there's a red 3 single that stays in. What does that look like at the end? 2 times 2 is 4, and then we still have a 3 on the inside. Okay, largest perfect square method. Half of 48 is 24, so I am not going to list any numbers bigger than 24. So we have 1, 4, 9, 16, 25 is bigger, so I know it's not going to be 25. But just to be clear, try to divide 48 by 25, you'll get a decimal, you would exclude it anyway. 48 divided by 16 is 3, that's the winner. So when we go to rewrite this, we choose 16. And what other number? Well, let's see. 48 divided by 16 is 3, so it has to be 16 times 3. The square root of 16 is 4, so that comes out. And my 3 stays under because the square root of 3 is a decimal. It's not necessarily that you're solving anything in these. You are just taking a square root and rewriting it into what we call a simplified form. This is the simplified form. But either way, look, we got the same answer. Pause the video and try to do, I would say this one, but that's a perfect square, and the principal root of that is 8. 8 times 8 is 64. Sometimes you don't have to break them down. Pause the video and try this one. What's the largest try to use the largest perfect square method. I usually reserve this method for when the number is really big. I usually reserve the factor tree for when the number is so big that I can't think of a perfect square that goes into it. But when the numbers are small, like 20, I usually go with the perfect square method. So what's the largest perfect square that goes into 20? Pause the video to think about that. All right, welcome back. What did you pick? Hopefully you picked 4. 4 times 5 is 20. The square root of 4 is 2. So our final answer is 2 square root of 5. Let's check it out. 2 square root 5. I'm going to hit submit, and there should be a check mark that's going to appear like over in this direction. Yay, we got it right. All right, I hope that helps. I hope that helps you understand the differences between the two of the methods. And soon we're going to look at, or next, we're going to look at what happens if you add a variable or a set of variables under the radical.